Life depends on the warmth of the sun being trapped by the layers of gases that surround the Earth. We now produce so much of these heat-trapping gases that the layer is getting thicker, heating the world, changing our climate, and changing our way of life. As the world gets hotter, the climate will change, and some of the extreme effects we have witnessed will become more frequent, making our planet a more hostile place to live. If we can see the gases, the cause of the problem will be obvious to everyone, and if you can see the effects they are having on our planet, you can do something about it. The solutions exist. It's not too late to make a difference, but we have to act now, today. There are many chemical compounds naturally present in the Earth's atmosphere, namely water vapor, carbon dioxide, and ozone. These compounds absorb the thermal radiation emitted by the Earth's surface and atmosphere. A significant portion of this energy then acts to warm the surface and the lower atmosphere. The average surface air temperature of the Earth would be about 30 degrees higher without atmospheric absorption and re-radiation of thermal energy. This phenomenon is known as the greenhouse effect. The gases that are responsible for this effect are referred to as greenhouse gases. Knowing that the role of greenhouse gases is maintaining the Earth's energy balance, the concern over the potential impact of the rising of greenhouse gas concentrations on the global climate system continue to rise each day. At the start of the Industrial Revolution, the concentration of carbon dioxide in the atmosphere was about 280 parts per million by volume. As Industrial Revolution spread, the consumption of fossil fuel, that is oil, gas, and coal, rapidly increased. By the late 1940s, the atmosphere's carbon dioxide concentration had risen to 300 parts per million. After World War II, automobiles became the favorite mode of transportation, and industrialization grew rapidly across the globe. Today, the concentrations of carbon dioxide in the atmosphere have risen to more than 360 parts per million. This increase is alarming because at the rate by which carbon dioxide is being released into the atmosphere continues to steadily increase. Studies have shown that daily human activities have increased the atmospheric concentration of a variety of greenhouse gases, and scientists are concerned about the rising atmospheric concentration of carbon dioxide. Over the past 100 years, the atmospheric concentration of carbon dioxide has increased more than 30%. The evidence for this rise comes primarily from the continuous observations of atmospheric carbon dioxide started in 1958 at Mauna Loa, Hawaii by Charles Keeling, and from parallel records around the world. Keeling's sensitive measurements have picked up the Earth's respiration. Every spring, the plants that bloomed sent carbon dioxide out of the air. Every fall, carbon dioxide was released back in the air as plants decayed. But Keeling noticed that year by year, the total concentrations of carbon dioxide increased. Superimposed on the annual cycle was a rising curve. Each year, more carbon dioxide was inhaled and exhaled by the biosphere. The Keeling curve proved what many have suspected, that humans were changing the composition of the atmosphere. Scientists estimate that the average annual amount of carbon released into the atmosphere during the 1990s was 8.5 gigatons. Approximately 6.3 gigatons was from combustion of fossil fuels and 2.2 gigatons from changes in land use. To put the number into perspective, if the average weight of a human is 70 kilograms, approximately 150 pounds, a gigaton would be the weight of more than 14 billion people, or more than 2 times the world's population. The differences in measurements must have flowed from the atmosphere into the other main pools in the global carbon cycle, the oceans and the terrestrial. The process of diffusion controls uptake of carbon dioxide from the atmosphere into the oceans. Because physical processes largely control this transfer, scientists are able to make reasonably accurate estimates. Using this approach, the Earth's terrestrial ecosystem are a net sink of carbon, with an annual net uptake of carbon from the atmosphere of 0.7 gigatons. However, due to land clearing like deforestation, it causes a discrepancy in the estimate. This problem is called the missing carbon. Some studies suggest any possible net uptake of carbon may be due to the reforestation of terrestrial ecosystems in the temperate regions. However, more recent studies suggest that the tropical forests represent a much larger sink of carbon than previously believed. A greater understanding of the processes controlling carbon exchange among the major components of the global carbon cycle, as well as how these exchanges might be influenced by rising atmospheric concentrations of carbon dioxide, is needed. When carbon dioxide diffuses from the atmosphere into the surface of waters, it undergoes chemical reactions, including its transformation to carbonates and bicarbonates. Concentration gradient functions as the rate of diffusion from the atmosphere to the surface waters of the ocean differs. Therefore, as the concentration of carbon dioxide in the atmosphere rises, the diffusion of carbon dioxide into surface waters increase. Since oceans have a very large volume, it has the capability to absorb most of the carbon that is transferred to the atmosphere brought by fossil fuel and land clearing. Oceans function as 2 layers, surface and deep waters. Depending on the amount of radiation that hits the surface, the zone of warm water can range from 75 to 200 meters deep, and a temperature of 18 degrees Celsius. Beyond the 200-meter depth, the deep waters have an average temperature of 3 degrees Celsius. Because of this, the ocean can be seen as a thin layer of warm water floating on a much deeper layer of cold water. The surface water gets mixed due to the turbulence caused by the winds. Carbon dioxide absorbed at the surface transfers below, but does not extend into the deeper waters because of the thermocline. Instead, mixing of surface and deep water is dependent on the deep ocean currents caused by the sinking of the surface waters as they move towards the poles. High levels of carbon dioxide concentrations in the atmosphere have 2 direct short-term effects on plants. First, the rate of photosynthesis increases, and second, it causes the stomata to partially close, reducing water loss due to transpiration, increasing their water use efficiency. C3 plant species respond most strongly to elevated carbon dioxide, with an average increase in biomass of 47%. Results on CAM species were limited, but the mean response was reported to be 21%. C4 species also responded positively with an average increase of 11%. In some studies, some plants produce less rubisco at elevated carbon dioxide concentrations, reducing photosynthesis or downregulation. Other plants grown at increased carbon dioxide levels appear to produce fewer stomata, and some allocate more carbon in the production of roots. Several large-scale experiments are currently being done to study the effects of increased carbon dioxide levels on whole ecosystems. Exposing areas of forests and grasslands to elevated carbon dioxide enables scientists to examine the variety of processes influencing primary productivity, decomposition, and nutrient cycling in terrestrial ecosystems. 1.74 degrees Celsius increase in the Earth's average temperature has taken place over the past 100 years. According to IPCC, most of the observed increase in global average temperature since the mid-20th century is likely due to the change in the amount of carbon dioxide in the atmosphere. By 2020, scientists estimate that the pre-industrial level of carbon dioxide will reach 380 parts per million in the atmosphere. Other greenhouse gases such as methane, nitrous oxide, HCFCs, ozone, and sulfur dioxide are very effective in trapping heat, thus making them important components of the total greenhouse effect. Compared to the role of greenhouse gases in warming the Earth's atmosphere, it is certain what doubling carbon dioxide concentrations of the atmosphere will exert on global climate system. As a solution, scientists developed general circulation methods, or GCMs. GCMs predict more than just hotter days. Notable predictions include more storms and hurricanes, greater snowfall, and increased variability in rainfall in specific regions. Climate influences almost every aspect of the ecosystem. Current research on greenhouse warming focuses on the response of organisms at all levels of organization: individuals, populations, communities, and ecosystems. The change in temperature and the availability of water will directly affect the distribution and abundance of individual species. Distribution and abundance of animals also directly relate to the features of the climate. The shifts in individual species distributions will have the effect of changing regional patterns of species diversity. Through decomposition and nutrient cycling, changing climate also affect vegetation indirectly. These processes depend on temperature and available moisture in terrestrial ecosystems. Ecologists have learned a great deal about the responses of terrestrial ecosystems and their changing climate conditions by studying past climate fluctuations. As Earth's climate has changed in the past, the distribution and abundance of organisms, the communities, and ecosystems it composes also changes. The world's oceans cover more than 70% of the Earth's surface. Millions of creatures, great and small, call the ocean home. These massive bodies of water play a crucial role in maintaining the planet's delicate environmental balance, from supporting a complex food chain to affecting global weather patterns. But rising temperatures are warming the oceans and bringing dramatic impacts felt all around the globe. Since 1950, the temperature has been observed to slowly rise about 1/100th of a degree per year. That small amount makes a difference because it goes on every year. You think about how big the ocean is, and how deep it is, and how much energy it has. It's a tremendous source of heat. Sea levels continue to rise as the glaciers melt due to the warming climate. Over the past century, sea levels have risen at a rate of 1.8 millimeters per year. The reason being the general pattern of global warming and the associated thermal expansion of ocean waters and melting glaciers. A large portion of the human population live in coastal areas. In fact, 13 of the world's 20 largest cities are located on coasts. Those being particularly vulnerable are delta regions, low-lying countries, and the smaller low-lying islands, especially those in the Pacific. A sea level rise will also have a major effect on coastal ecosystems. Patterns of water depth, temperature, salinity, and turbidity are critical to maintaining ecosystems like estuaries, mangroves, and saltwater marshes. Despite technological advances in improved crop varieties and methods of irrigation, climate and weather remain the key factors determining agricultural production. Changes in the global climate patterns create an already increasing problem of feeding the world populations, which is expected to double in size over the course of the next 50 years. Previous researchers suggest that during the early 1980s and 90s, warmer temperatures and higher levels of precipitation were generally good for plant growth. Although studies have shown that crop production increases with the rise in carbon dioxide levels, the rise in temperature due to climate change affects agricultural zones, changing regional land use patterns and causing longer and more frequent droughts. An increase of just 1 degree showed a northern movement of more suitable farming area for studies done in the United States and Japan. The Environmental Change Unit at Oxford University has carried out a collaborative study with scientists from 18 countries to study the regional and global impacts of climate change on world agricultural production. A major finding of the study is that the negative effects of climate change are to some extent compensated by increased productivity resulting from the elevated concentrations of carbon dioxide. Climate change will have an effect on human health both directly and indirectly. Directly, it would cause an increase in heat stress, the number of those who have asthma, and cardiovascular and respiratory ailments. Indirectly, it would cause an increase in the number of incidences of communicable diseases and mortality and injury due to natural disasters, and changes in diet and nutrition due to a change in agricultural production. Maximum summer temperature. To understand the effect of rising atmospheric concentration of greenhouse gases and global climate change, we have to study the Earth as a single complex system. If a part of the whole collapses, then the whole thing will fall. If the temperature continues to rise, the distribution and abundance of the rainforests will decline dramatically, leaving us with unimaginable levels of carbon dioxide in the atmosphere. Without snow cover, the amount of solar radiation reflected back into space will greatly reduce, further increasing regional temperatures. Now, after everything you've learned, can you imagine what kind of world you'll be living in the next 10 years? In the next 20? What kind of world are you leaving behind for your children? That is, if there is anything to leave behind. Just like how a smile is contagious, so are actions. We each hold the capacity to make small changes, and eventually, as a whole, create a big one.